Very good morning, good afternoon, good evening my dear friends. Welcome to this data analysis and decision making 1 course under the NPTEL MOOC series. And this is, as you see, this is the 19th lecture, and this course is for 12 weeks, 30 hours, each week being 5 lectures, each lecture being for half an hour, and we are in the 4th week, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, in the end of the 18th lecture we are discussing the table where you had two statements, which is the H naught and H A, which is alternative hypothesis being for H naught H A, and this H naught being basically the hypothesis which you want to disprove, which is the actual statement based on the fact that what is the information which is being given by the provider. That means, whose statement you are going to disprove, which is the null hypothesis H naught. Now, as I also said that with respect to the mother nature and the information being provided by the person whom you are going to disprove and your plan of action also, there can be such 4 different outcomes. In one case, it can be where I will just use the simple words in order to make you understand. Consider H naught being true actually, and you are proving that H naught is true. So, there is no error. Another case is that H A is true and you are proving H A is true, there is no error. I am using the word H naught and H A in the simple sense. The other two cases are H naught being true, but H A is being proved true. So, there is an error. And the fourth one is H A being true and H naught being proved true, there is another error, which is basically the alpha and beta. And what is alpha and beta? I will try to basically explain that with a simple example. Now, in this hypothesis testing, remember, whenever you are making the hypothesis testing, the fact remains that these outcomes or the rules which we will consider are all coming from the case of interval estimation and point estimation. So, there is no new concept which are being going to be discussed here, only the way how you tackle the problem would be basically more relevant. So, consider this case, and I will basically build up a story here. Consider you are a bank manager in a public sector bank or a private bank, whatever, and your the company or the organization or the bank, they have said that you should disburse loan, and the loans are such that you would basically agree to the fact that giving the loans would mean that you want to basically have a set of information being provided by the customer, so that you can make your loan decision accordingly. Consider there are different type of questionnaires. Questionnaires being what is the person's age profile, where is the person working, is it a government organization, is it a private organization, does he or she have a business, what is his or her residential address, does he or she own a house, does he or she own a car, or does he or she own a scooter, is the spouse of that person working, what is does the person have a bank account in that bank, or does the person has the person ever defaulted, and all these things and are being provided or asked from the person who has asked for a loan. And for each of these there are some points. So, my bank manager, which is you provide some points for each of these questions and basically collate the points, add those points, and if the number of points is basically, say for example, 60 and above or 70 and above, consider whatever it is, 60 and above, and then the loan is sanctioned. So, consider for the time being the green line which is there in front of you is the line which basically demarcates the point 60. So, any person on to the right whose score is there would be given that loan, any person on to the left of the green line, that means, as you see this slide, on to the left of the line would not be provided any loan. Now, then you will be asking what are these red and blue curves. Now, each person who is being whose score is basically more than 60. So, technically that person would have different scores. So, if that there are different scores, we will mean that the distribution of the scores for our case we are considering a simplistic example, the person would basically, or the set of persons the scores would basically be normally distributed. So, the blue line which you see is the normally distributed score points for the persons who would definitely be given a loan. Now, on the same context, the set of persons who would be denied the loan would also have a distribution. We will also consider the distribution to be normal, and that normal distribution is again given by the red line. Now, red curve. Now, remember this blue dotted line vertical and the red dotted line vertical are the average scores which would be there corresponding to the set of people who are given the loan, and the set on the red line dotted line is basically set of is the average score for those set of peoples who would not be given the loan. Now, see the green line passes in such a way that they are two areas, and what are these two areas? I do not want to basically mark anything because it has been colored quite nicely. So, it is easy for you to understand. So, consider this red hashed lines. This red hashed lines actually means these are the people to whom erroneously we give the loan, but the probability of getting back the loan is 0, such that it would basically be a bad debt for you as the manager, bank manager. On the other hand, the blue hashed lines which is on the left hand side where I am hovering the pen are those set of peoples who should have been given the loan, but they are denied the loan, which means that in the long run they are opportunity cost lost, which is business loss. Now, if I consider that these are both errors, that means the red hashed line are those set of peoples who should not have been given the loan, but they are given the loan, and the blue hashed lines are those set of peoples who should have been given the loan, but they are denied the loan. So, one is basically bad debt and the second one is basically opportunity cost lost. Now, these are errors, as I mentioned, these are the alpha and beta errors which I have just discussed in the table beforehand. Now, see the peculiarity of this interesting example. So, obviously, you will be tempted to reduce beta and basically reduce alpha also. So, obviously, if both are 0, then your life is done, because you would never give a loan to a person who would basically bad debt, the person would not return the loan, and the blue one obviously all those set of peoples you would definitely like to give the loan, because that would, or else it would be a opportunity cost lost for you. Now, consider the green line is shifted vertically either onto the left or the right. So, it is, and I am basically talking from my own perspective. So, it is basically removed to the left, it would mean that beta increases and alpha decreases. On the other hand, you try to basically shift the green vertical line onto the right. So, in that case beta decreases and alpha increases. Now, which means that trying to basically reduce both of them at the same time is not possible. So, what you will try to do from the statistical perspective is basically try to minimize the sum of alpha and beta, and then basically try to solve the problems accordingly. So, when you are trying to basically do the hypothesis testing, you will keep the values of beta fixed at a certain level, and then basically try to understand what is the value of alpha. And if you remember that alpha is basically related to 1 minus alpha, which is the level of significance. So, in this problem it basically states, and the table also which we saw earlier, is that there would be two type of errors, alpha and beta, and we will try to basically see that how it can be reduced in, how the problem can be stated in such a way that given the set of information from beta, we will try to basically find out that what is alpha, and based on the alpha we will try to do the experiment accordingly. So, let us basically consider now the rules, and remember the rules are exactly what we have done in the interval estimation. So, there is no change, and even if they are changed, I will basically make all the things clear to you, and once the rules are basically covered, I will come to the problem solving later on. So, consider the first rule. In this case, you are trying to basically test the hypothesis, a null hypothesis, that mu is equal to mu naught, versus the case that in under H A, which is the alternative hypothesis, the mu A value is less than mu naught, which means that mu A value would be onto the left of H A mu naught. So, now I will basically draw the diagram in order to make you understand. Now, when you, and I will use the red color here. So, what you want is certain portion onto the left and you want to basically prove or disprove this, and consider this distribution is normal. So, the mean value for the normal distribution under H naught would be basically mu naught. So, what you want to find out is that mean value which is given, you will try to basically find out that this is, you will ask a question, yes, this is a test something to do with the mean. So, if that is the case, obviously you will know that it will be either the Z distribution or the T distribution. Then you ask the question, is the standard deviation of the variance of the distribution known? The answer is yes. If the answer is yes, obviously you will use the Z table. So, now if it is the Z table, what you will try to do is that you will try to basically find out the LCL in that case such that any x bar mean, which is the mean value of that sample which you are taking up, is onto the left hand side. You will basically reject H naught based on the overall problem formulation which has been done. So, what you want to do is that you will try to basically find out the mean value for the sample. If the mean value of the sample is lying on the left hand side, so this is what, this is H naught which is here, and this value sigma by square root of n is basically based on the fact that the x bar n, which is the mean value of the sample, is distributed normal with a mu value of as the mean or the expected value, and the variance being sigma square by n. Hence, basically when you convert it to a z normal value, it will be x bar n minus mu by sigma by square root of n. So, hence this is going here. So, if mu x minus, now where does that z alpha combine, and remember that I am harping on the fact that is z alpha. So, it will change depending on the example. Two things will change. Number one, whether z is the case or it should be t, because you remember that t would be the case when the standard deviation or the variance of the population is not known, point 1, and obviously t would have its own corresponding degrees of freedom which is not there for z. The second thing is, remember that alpha value which you are putting in, now many of the cases it would be 1 minus alpha or alpha by 2 depending on the example. So, these words may not be making any sense to you immediately, but as you see the diagram it will become clear to you. These diagrams I will basically draw as we proceed with the problem solving or explaining the concept. Now, in this case x bar n should be less than onto the left hand side of mu naught minus this value, that means you are finding out some z alpha here, and this z alpha is minus. So, obviously, this would be how far the standard deviation is from the mean value, and the value of z alpha basically gives you what is the level of confidence which you have. Now, the level of confidence is very important, let me consider. So, if you are talking about the level of confidence which is 1 minus alpha, so if this whole area is alpha, then in this case the area onto the right would basically be 1 minus alpha. So, the whole area which you are covering under the distribution, one part is alpha which is left, and the right hand side is basically 1 minus alpha. So, hence you will basically, the rule is that you will reject H naught if x bar n is less than mu naught minus z alpha sigma by square root of n. Now, before you proceed to the next rule, I will basically build up the story here. Now, consider that you want to find out that the null hypothesis is mu is equal to mu naught versus alternate hypothesis is mu is equal to mu a, but the fact is that mu a is onto the right hand side, which means that is greater than H naught. So, what do we do? So, in this case obviously you have to consider the right hand side, which is where I am hovering the pen, and the rule would be like this. So, this is mu naught, this is the value, this is z alpha, and this will be 1 minus alpha, which is the level of significance. This is mu naught, this value is alpha, this value is 1 minus alpha. So, in this case you will try to basically find out and reject H naught if x bar n, which is the sample mean, is onto the right hand side of the upper control limit, which is mu naught plus z alpha into sigma by square root of n. This value of sigma by square root of n is constant. This z alpha is now here. This plus sign is coming due to the fact this is onto the right hand side. In the other case, it came due to it was on the left hand side. Now, the third problem. So, if the what you are seeing are exactly the lower control limit and the upper control limit for the less than type and the greater than type. Now, the third question for the similar type of problem, for finding out something to do with the mean, where provided the mu value as shown here, where I am basically pointing my finger, is that sigma square from the population is known. What happens to the problem if now we frame the problem as H naught, mu is equal to mu naught under H naught, and under H A mu is equal to mu A, but mu A is not equal to mu naught. That means, it can be either on the left hand side or the right hand side. So, how do we frame the problem? Now, let me draw the diagram. This is mu naught, this is minus z alpha by 2. Remember this is by 2, this I am harping time and again, and I will come to that again. This is z alpha by 2. So, this area is alpha by 2, alpha by 2, this area is now 1 minus alpha. Now, see the problem here. Problem means not the problem that we are facing, but how we are basically able to frame it. Now, in this case, as I said, mu is equal to mu naught and under H naught, and under H A mu is equal to mu A, but mu A is not equal to mu naught, and sigma square, which is the population variance or the standard deviation square for the population, is known. So, in this case you will reject H naught if the sample mean is onto the is basically given the fact that it is either on the left hand side or the right hand side, or it can be the complementary set of it is not in between. Now, the values which you have put for z alpha by 2 are being put in such a way that the right hand side of the area onto the right hand side of plus z alpha by 2 is alpha by 2, and you are basically considering a symmetric distribution, and the left hand side of the area onto the left of minus z alpha by 2 is also alpha by 2. So, whole the sum is basically alpha by 2 by n alpha by 2 is alpha, and obviously, the middle area, which is the level of confidence which you have already formulated depending on the problem formulation which you have already seen for the interval estimation, would be 1 minus alpha. So, in this case what we do in these 3 examples, not the examples, I would not say 3 different formulations of the same problem, is that in one case it is less than time, the second case it is greater than time, and the third case is basically not equal to, and you basically utilize the same problem formulation for the interval estimation, but remember that for the less than time it will be minus z alpha, for the greater than time it will be plus z alpha, and for the not equal to it will be minus z alpha by 2 plus z alpha by 2, such that the interval which you have is basically 1 minus alpha, which is the level of significance, and that can be either onto the left hand side or on the right hand side, or it can be in the middle depending on how you have basically been able to formulate the problem. Now, the question is that we are going to answer. Now, if this things clear, you will basically ask that what happens and how do we frame the problem for the hypothesis testing if the case is that we want to find out something to do with the mean of the population, provided the standard deviation of the population or the variance of the population is unknown. Then do we use the same distribution z? The answer is no. What distribution will we use? We will use the t distribution, and obviously there would be corresponding degrees of freedom, which I will basically now explain. Now, consider the hypothesis testing as H naught, mu is equal to mu naught, versus H A, which is mu is equal to mu A, but mu A is less than mu naught, and in the case that sigma square is unknown. That means, the population variance is unknown. So, in this case again you have the same type of distribution. I am using the figures are not important, what is important is basically where the values lie and which side. So, consider this is the t distribution, this now would basically be the t value. So, in this case if x bar n is onto the left hand side, let me, so this area would basically be alpha, so this is the level of significance which you have, and this would be given by n minus 1, remember that is important, and alpha, because alpha is basically onto the left hand side. Why it is n minus 1 alpha? Because you have utilized 1 degrees of freedom, hence as you have lost 1 degrees of freedom trying to find out the first moment which is the mean, hence t distribution would basically would have lost 1 degrees of freedom, which is basically now become n minus 1. So, in this case the sample mean should be less than equal to the population mean under h naught is mu naught minus the value of t n minus 1 into alpha. This is this value which I have. I am just giving the concept without the sign for t is t n suffix n minus 1 alpha, and S n, why S n? Because you have already not, you have do not have any information on the population mean. So, you will use the sample mean as the best estimate for the population mean, and as you have used the set of observations 1 to n for the first time to find out the best estimate for the population mean using the sample mean, hence the degrees of freedom is reduced by 1, and obviously this would be square divided by square root of 1 as the formula it is. Now, the question would arise that what is the hypothesis for the case when it is greater than time? In that case h naught, under h naught you have mu is equal to mu naught, under h a mu is equal to mu a, but is greater than h naught, and sigma square which is the population variance is unknown. And simply in this case it is on the right hand side. So, this would basically be t n minus 1 alpha, this area is alpha, this area is 1 minus alpha, so we basically utilize in such a way that the left hand side is 1 minus alpha, which is degrees of freedom in this case, other it was degrees of freedom, degrees of freedom is basically n minus 1, the level of significance is 1 minus alpha, and here t n minus 1 would basically be the statistic based on which you will basically do the test. So, this is a greater than type, and this sample mean should be on the right hand side, that is mu naught under h naught plus the value as you are moving on to the right hand side depending on the level of significance, that value is t n minus 1 alpha into S n by square root of n. Third similar type of problem under this concept is what is the rejection rule or the rule based on the fact that under h naught mu is equal to mu naught, under h a mu is equal to mu a, but mu a is not equal to h naught, and sigma square which is the population variance is unknown. So, again same t distribution, I am trying to basically draw the diagrams in order to make you understand. So, these are the t values. So, this is t n minus 1, t n minus 1. Now, look at this important thing, this whole area would be alpha by 2, this whole area onto the right is alpha by 2. So, hence that total addition is alpha by 2 by alpha by 2, and hence the degree the level of significance for this is alpha by 2 and this is alpha by 2, such that the overall area which is in between is 1 minus alpha, which is level of significance. So, you are basically trying to redefine the lower control limit and the upper control limit. In the lower control limit it is mu naught minus, and what is the minus value is t n minus 1 comma alpha by 2 into S n. S n remains the same because you are utilizing the S without the dash provided you have lost 1 degrees of freedom, because the population mean is not known, you utilize the observations from the sample in order to estimate the population parameter, hence you have lost 1 degrees of freedom, divided, and here the Sn would be divided by square root of n. In the other case, when you go to the right hand side, everything remains the same. It is the upper control limit will be mu naught plus T n minus 1 comma alpha by 2 into Sn divided by square root of n. So, we have already seen that the rules, that how you will basically formulate the hypothesis testing rules, provided the sample mean was being utilized in order to basically find out some hypothesis statements related to the population mean. And in the first 3 instances, because the rules are 3 for the case when the variance was known. So, you use the z distribution. Once on the left hand side, they use z alpha. I am just harping on the statistic z alpha with a minus sign, obviously, because on to the left. The second case is that, and the first case obviously in that case it was the H naught was less than type. In the second rule, under the case when you want to find out something to do with the hypothesis testing for the population mean, provided the variance was known and it was H naught was of the greater than type, then the rule was basically something to do with onto the right hand side, where it was z alpha, and obviously minus and plus would come if they are less than type and greater than type. When the rule was basically to try to find out something to do with the null hypothesis, and the alternative hypothesis was H A, where H A basically states that mu A is not equal to mu naught. So, in that case the z values becomes minus z alpha by 2 and plus z alpha by 2, because the left hand side area and the right hand side area are equally dispersed. So, hence the sum is basically alpha and the level of confidence which you have in between is 1 minus alpha. Then we basically went to the fact that we want to find out something to do with the hypothesis testing corresponding to the sample of the population mean using the sample mean, but the variance of the population is unknown. Hence, we will basically utilize the case that we are using the t distribution, but losing 1 degrees of freedom, because the population mean not known. Hence, you will try to utilize the sample mean as the best estimate. And there we basically found out that if it was less than type, for the case for H naught, where mu A is less than mu naught, provided the population variance is unknown, we use the t distribution minus t n minus 1 comma alpha, and obviously it will be S n divided by square root of n. When the case, the second rule was basically H naught, where H mu A is greater than type of greater than mu naught. So, you will basically utilize the plus value, and it will be t n minus 1 comma alpha into s divided by square root of n. I am only harping on the right hand type, the other values where mu naught remains the same. And in the third rule, basically we saw that if it was not equal to rule, that means under H naught H A, if mu A was not equal to H mu naught. So, in that rule you basically have the left hand side and the right hand side. Left hand side basically would be t n minus 1 alpha by 2 into S n divided by square root of n, and in the other hand it will be, for the right hand side it will be plus t n minus 1 alpha by 2 into S n divided by square root of n. So, obviously, we will see that how we can formulate the problem for the standard deviation, how we can formulate the problem provided the mean value being known or not known. We will continue discussing that in the 20th lecture, which will basically be the last lecture for the 4th week. Have a nice day and thank you very much.